Alright, so this video is part of a compilation of videos I've done on Epsilon-Delta proofs, and if you want to see the full compilation, there's a link down in the pinned comments below. But I hope you love this standalone video just to digest this one proof, and I'm excited to bring it to you right now. So we have the first one, which is limit x goes to 3 of 5x minus 9. The first thing before we prove what this limit is to actually calculate it. So here we just plug in x equals 3, it's a continuous function, so we get 15 minus 9, which is equal to 6. So we need to rigorously prove that it's equal to 6. So what I just said is not a rigorous proof, and we're going to do the epsilon delta definition. Now what does that really mean? Well, what this limit is saying is as x approaches 3, 5x minus 9 approaches 6. So we want to make the absolute value of 5x minus 9 minus 6, we want to make this small as the absolute value of x minus 3 becomes small. The absolute value of x minus 3 is the distance from x to 3. And this is the distance from 5x minus 9 to 6. So another way of saying it, which is the epsilon delta formulation, is that no matter how small, it's a game we are playing, no matter how small I want to make this number, right? I want to make it less than epsilon. You will tell me how close x has got to be to 3 in order for this to be less than epsilon, for this distance between 5x minus 9 and 6 to be less than epsilon. So you're going to pick a delta. So that absolute value x minus 3 less than delta implies that the absolute value of 5x minus 9 minus 6 is less than epsilon. Another way of saying that is that for each epsilon greater than 0, for each degree of closeness from 5x minus 9 to 6 that I choose, you can find a degree of closeness from x to 3 that ensures that as long as this degree of closeness from x to 3 is satisfied, absolute value x minus 3 is less than delta, this is going to be satisfied. 5x minus 9 minus 6 is going to be sufficiently small. So your delta we want to find is going to be solved in terms of epsilon. Okay, so we want to pick a delta in terms of epsilon because as epsilon gets smaller, we need delta to also be smaller. So delta is a function of epsilon, and we're going to basically start off by manipulating this expression and finding what delta should be and then writing our rigorous proof. That's how epsilon delta proofs are done. You first figure out what delta should be and then you write the proof. You backtrack before the proof. So here we're going to say, okay, the absolute value of 5x minus 9 minus 6 is the absolute value of 5x minus 15, okay? And we want to make this small, knowing that absolute value x minus 3 is small, okay? We want to figure out how small this has got to be, so this is small. So we need to express this in terms of absolute value x minus 3. That's going to be the general philosophy. So we can write this as 5 times the absolute value of x minus 3. That was nice enough that we could express this as 5 times the absolute value x minus 3. So what does delta have got to be so that this is less than epsilon? How do we ensure this is less than epsilon? Well, as long as absolute value x minus 3 is less than epsilon over 5, right? If we take delta equals to epsilon over 5, then 5 times the absolute value x minus 3 will be less than epsilon. So that's going to be the principle, and now we write the rigorous proof. So this is all there is to it, okay? Takes some time to get used to it, but that's all there is to it. And the rigorous proof looks as follows. We simply say that let epsilon greater than 0 be arbitrary, okay? So I'm going to be very precise. You can actually do this as a blueprint for all of these proofs. Let epsilon greater than 0 be arbitrary. That's the degree of closeness. That's saying how close do I want this quantity, how close do I want 5x minus 9 to be to 6, okay? And that's my epsilon. So the epsilon greater than 0 will be arbitrary. So what we're going to do is going to say that if delta is equal to epsilon over 5, so if absolute value x minus 3 is less than delta, then this is going to be less than epsilon. So how the proof's going to go is if delta is equal to epsilon over 5, then absolute value x minus 3 less than delta implies that, what does it imply? It implies the absolute value of x minus 3 is less than epsilon over 5, which implies that 5 times the absolute value of x minus 3 is less than epsilon, which finally implies that the absolute value of 5x minus 15 is less than epsilon. So no matter what epsilon we picked, okay, and 5x minus 15 is very important to write it as the absolute value of 5x minus 9 minus 6. Okay, that's going to be less than epsilon. So no matter how close I wanted 5x minus 9 minus to be to 6, I could ensure that if delta was that epsilon over 5, then as long as x was that close to 3, then 5x minus 9 would be that close to 6. Okay, so just repeated myself a lot here, but I want to drill in the concept. Okay, We're just trying to solve for delta in terms of epsilon in each of these proofs. And we've done that, and then once we've done that, we need to write out the proof in this way to start off with epsilon greater than 0 being arbitrary. Let's get on to the next one now, okay? So the next one is going to be quite more interesting, okay? So let's get into it.